good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Indicates. Okay, so we have been discussing about the refraction through lens, and we have also in the previous two classes we have discussed about what are the types of lens, spherical lenses, what are the types, and we have also discussed some technical terms related to lens. Okay, now in today's class we will be discussing about how the images are formed for the various positions of the objects for a lens. It may be a concave lens or also a convex lens also. Okay, so let us quickly move on to our topic. So today our topic of discussion is formation of image in spherical lens. Okay, so before starting, we will be actually say for finding out the position of the image or the nature of the image formed by a lens, what you need to do, you need to draw a ray diagram. Now, in order to determine position and the nature of image what we need to do, we need to do two things. One is we have to actually take two rays, at least two light rays for the formation of the image. Okay, so remember this point that we have to at least take two incident rays. So at least two incident rays have to be taken to form the image. Okay, to form the image. Remember this point. This is a very important point. Okay, so which two rays we will be taking for formation of the image in a lens? Let us discuss those incident rays. Okay. So see, there are some basic rules that you need to know about. These rules have been found experimentally. So you just need to learn those rules and just keep it in mind. Okay. So what does the rule number 1 says? So remember this part, you have to take at least two incident rays, okay, to form the image. Fine. Now, what are the basic rules or basic incident rays that we must be taking to form or to get the image at the proper position? So, first rule. Okay. So, what does the first rule says? The first rule says that whenever a beam of light or a ray of light is coming from an infinite distance and it is coming in such a way that it is coming parallel to the principal axis, remember this, then for a convex lens it will, after refraction to the lens, it will pass to the focus. Okay, and for a concave lens the ray will get diverged in such a way that if we trace it back, we will be seeing, or it will be looking like, appearing to be as if that ray is getting diverged from the focus. So just let us draw the diagram, the concept will be clear. So this is a convex lens. Okay, so this is a convex lens. So if we consider a convex lens, what happens? In case of a convex lens, as I said, that if I take a ray which is coming parallel to the principal axis, after refraction it will pass the focus. Say there are, already in the previous class we have discussed that we have told that there are two focal point in case of lens, isn't it? So let us just consider this first focal point and this to the second focal point F1 and F2. So if a light ray, what happens? If a light ray comes parallel to the principal axis, what happens after refraction? It will pass through the, like this, it will pass through the focus. So like this. Okay. Remember, it is very important to consider the arrows while you are drawing a ray diagram. Without showing the arrow, it will just simply mean a plain line. Okay, so we just need to give these arrows to demonstrate that these are the actually light rays. Okay, so first rule is that whenever a light ray is coming parallel to the principal axis, after refraction it will pass to the focus in case of a convex lens. What about a concave lens? Let us just see what about a concave lens. It will be something like this. Concave lens, and just extend this line. Okay, for a concave lens also there are two focus, isn't it? There are two focus. So let us consider one focus to be here f1 and the other focus to be at here f2. These focus are actually at equal distance from the optical center. This is optical center, isn't it? This is optical center, or this point is the optical center. So actually the focal points are at equal distance from the optical center, f1 and f2. If it is a biconcave or biconvex lens, remember this. Now, if a light ray is coming parallel to the principal axis, you know that for a concave lens it will get diverged, isn't it? How will it be diverged? It will be something like this. So, I think the concept is clear. Okay, it will be diverged in such a way that it will look like the ray is being diverged from this focus or focal point. So this is one of the ray that we can be using to get the image, or the position of the image, or rather nature of the image. Okay, fine. Now let us move on to rule number 2. So I think rule number 1 is clear. If not, please pause the video, move back a little bit and see it once again. I think it will be clear. Okay. Now at the end of this part, or at the end of this part of the chapter, I will be discussing how to exactly draw the ray diagrams. Don't worry about that. I will be giving the exact measurements that you must be taking while drawing these ray diagrams in your copy. Okay, so the figure will be coming exact. That is no problem. Okay, now coming to rule number 2. So just let me erase these rays only. I will be not rubbing out the lens figure. Okay, it will be, so you can save time like that. But in your copy you have to draw the diagrams 3 times, as we will be discussing about 3 rays, 3 principal rays that you can consider or take while drawing the ray diagram. Now moving on to rule number 2. So what is rule number 2? What is rule number 2? Let us see. What is rule number 2? Okay. Now rule number 2 says that whenever a light ray is incident on the lens from the focus, means that the light ray is coming from the focus, then after refraction it will move out parallel to the principal axis. Let us see how. So if a light ray falls on the convex lens like this, so it is passing, see, it is passing to the focus. So after refraction what happens? It will just come out parallel to the principal axis. Fine. For a concave lens, how it will be coming? It will be coming like this, say. So if this is in the focus, the light ray will be coming something like this. Okay, and after refraction it will become parallel. So for a concave lens, it will be appearing to be such that the light ray is incident in such a fashion that it appears that it will go on to join the focus, but it is not actually joining the focus. Okay, and after refraction it will become parallel to the principal axis. So I think the concept is clear. Just the reverse concept of the previous concept that I have discussed, just the reverse. Okay, so this is the second law. Fine. Okay, now considering the, so you have, I think you have, the concept is clear. Now the third point, coming to the third point, third ray that you can consider. Okay, so just let me erase it. and then I will draw the figure once again. You mention it in your copy as figure 1, 2 and 3 because it is not possible for you to just erase it off like I am doing. Fine. Now, what happens in when I have defined optical center, I think I have discussed one thing, that optical center is such a point through which what happens, the light ray that is incident, if it passes through the optical center, it emerges out parallel to the incident ray, isn't it? But it is slightly displaced from its path, so it is kind of lateral displacement, as you have seen it in thick glass slab. But if the lens is very thin lens, then in that case optical center can be treated as that point at which if the light ray is incident, it will pass out undeviated. Now in our syllabus, the lens that we are considering are all taken to be thin lenses. So in that case, you can also consider another light ray, which is actually what happens if it passes to the principal axis, optical center, then it will pass out undeviated. So something like this, yeah. So it will just come in and move out undeviated. Okay. And in case of concave lens, also same thing happens like this. It will just come in and move out undeviated like this. Okay. So this is the third rule. Okay. So we can also consider this light ray that it is incident exactly at the optical center, it will pass out undeviated. So this is the third ray. So these are the three rays that we should be considering while drawing a ray diagram. Okay. Fine. Now before moving on to the ray diagram, actually we will not discussing the ray diagram in today's class, we will be doing it in the next video. In today's class we will be discussing another topic which is called the real image and the virtual image. It's an important topic, sometimes the reference also comes in the examinations. So I think these three rules are clear. Now let us move on to the difference between real image and virtual image. Okay. So what is real image and what is virtual image? Okay. So just make a heading: real image and virtual image. Okay, virtual image, real image and virtual image. So let us consider what are this real image and virtual image all about. Okay. Okay. So real image and virtual image, what happens? Say if we consider a convex lens. Okay. So if I consider a convex lens, what happens? In case of a convex lens, actually the light rays after refraction is actually meeting at some point. Say if two light rays are coming parallel to the principal axis, so after refraction, what happens? They will actually meet at a point. So like this, if two rays are coming like this, it will just pass to the focus. So these two light rays will actually meet at a point. See, it is actually intersecting at a point. So image is formed wherever two light rays actually intersect. Now when these two light rays intersect, this image, this kind of image that is formed is a real image. But if I consider a concave lens, say a concave lens like this, in a concave lens the problem is that the light rays are actually not meeting at a point. Say if I draw the figure, if two light rays are coming out like this, it is going out, and like this it is going out. Okay. So after refraction they will be actually not meeting, but if I just consider that they can be traced back, so it will be appearing that they are meeting at this point. It will be appearing to be meet. They are not actually meeting. So I think the difference is clear. They are not actually meeting, but they will be appearing to meet at. So this is the main factor. So in this way you can consider that the real image and virtual images are formed. So to differentiate, you can say that real images are formed when actually two light rays intersect or meet at a point actually, And in case of virtual image, the light rays don't actually meet or intersect at a point, rather they appear to meet or they seem to meet at a point. They are not actually intersecting. So that kind of image is regarded as a virtual image. Okay, fine. Now, so these are the two kinds of image, real and virtual. Now, real image, actually, if I keep a screen here, the real image can be captured on the screen. So real image can be captured on screen, but whereas for a virtual image it cannot be captured on a screen, Fine. Another, there is a point of difference. For a real image, the real image is always, remember this point, is inverted. Real image is always inverted, that is, it gets the image of the object will not be in the same direction, it will get inverted. Okay, we will be clearing this point when we are drawing the ray diagrams. And in case of virtual image, it is always erect, or you can say upright. Remember these points. Okay, upright. So these are actually the main differences between real and virtual image. Real image is actually formed by what happens here? Actually, the light rays are meeting at a point. Rays are actually meeting, but here rays appear to meet at a point. Okay. So these are the major differences between real image and virtual image. Okay, fine. So today we will be ending our class here. In the next lecture, we will be showing you how to find the positions of the different images found by the keeping the objects at different positions, and we will be discussing how you will be drawing those figures in your copy. We will be also discussing this, and then in the next lecture we will be discussing about the problems. Okay, so till then, till the next video, please do study well, and if you have any query, any question related to the topics, you can ask in the comment section. We will be definitely clearing your doubts. We will be happy to clear your doubts, so please do mention in the comment box. And till then, please do study well. Take care. Goodbye. Thank you.